Hello, this is Mr. Brooks, and welcome to Lesson 7.3, Proving Triangles Similar. In this lesson, we're going to learn how to use the AA similarity, SAS similarity, and SSS similarity statements. We're also going to learn how to apply all three of those similarity statements. Our first similarity postulate is the angle-angle similarity. Which states if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Now remember, as we learned in lesson 7.2, similar means all the angles are congruent and the sides are proportional. So if two angles are congruent, then you know your third pair of angles have to be congruent, and that will also mean all three pair of sides are proportional. Now let's look at example 1 and see if we can figure out if these two triangles are similar, and if so, why? Well, it already tells you that they are, but the reason is because these vertical angles are going to be congruent. And since angles R and V are given to be congruent, we can say the triangles are similar by AA similarity. Now, let's ask us to write a similarity statement. Please pause the video while you try to figure this out. If I name the triangle on the left triangle RWS, how must you name the one on the right in order for the two triangles to be similar? Hopefully, you're going to say triangle VBS. Now, quick check number 1 asks us if we have enough information to write a similarity statement, which we just did. We said triangle RWS is similar to triangle VBS. It also asks us, do we have enough information to write a similarity ratio, which we do not, because we do not know the lengths of any of the sides. Our next similarity statement is the SAS similarity theorem, which states if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles are proportional, then the triangles are similar. Now let's take a look at example 2 and see if we can understand the SAS similarity theorem a little bit better. Alright, we've got a pair of congruent angles. Angle R is congruent to angle Y because they're both right angles, and all right angles are congruent. Now, the sides that include those two angles are proportional. If we set up a proportion, we've got 3 over 4, and if that equals 6 over 8, which the cross products are both 24. So, since you got a pair of angles that are congruent, and the sides including those angles are proportional, the triangles must be similar. Then it asks us to write a similarity statement. Please pause the video while you do this. If I call the one on the left triangle PQR, how must you name the one on the right in order to get full credit? You're going to say triangle ZXY. So the triangles are similar, and they because they've got a pair of angles that are congruent and the corresponding sides are proportional. And the similarity ratio for these two triangles would be 3 to 4. Our next similarity statement is side-side-side similarity, or SSS similarity, which states if the corresponding sides of two triangles are proportional, then the triangles are similar. You don't need to know anything about the angle measures at all in order to get the triangles similar. Now let's take a look at quick check number 2 to see if we can better understand SSS similarity. Well, here we've got a couple isosceles triangles. Isosceles triangle ABC and isosceles triangle EFG. You can tell they're isosceles triangle because they both have at least two pair of congruent sides. So first, we're going to see if the sides are proportional. We're going to set up a similarity ratio. I'm going to go in this order, 6 over 8, and see if that equals 6 over 8, and see if that equals 9 over 12. And as you can see, all of these fractions reduce to 3/4. So The cross products are always equal, and so the sides are proportional. So the triangles are going to be similar. The similarity ratio is 3 to 4, and if I call the triangle on the left triangle A, B, C, how must you name the one on the right in order to get it right? Now actually, there are going to be 2 acceptable answers for this. See if you can come up with both of them. Hopefully you will agree that you can say triangle ABC is similar to triangle EFG or triangle FEG. The C has to correspond to the G, but the A can correspond to the E or the F, and the B can correspond to the E or the F. Now let's see if we can apply the AA similarity, SAS similarity, and or SSS similarity. Let's take a look at example 3. It says, if the triangles are similar, find DE. So the first thing we have to decide are these 2 triangles similar? Please pause the video while you try to figure this out. Well, hopefully you'll agree that angle ABC and angle EBD are congruent by vertical angle theorem. Next we have to see if the sides that include those angles are proportional. So AB over EB, 12 over 18, and see if that equals 16 over 24. Now to solve this you can either use cross products, or I'm just going to reduce both fractions to 2/3. Alright, so since they both reduce to the same thing, they are similar by SAS similarity. Now, how would we get DE? Please pause the video while you set up a proportion to figure out DE. Hopefully you agree that AB over EB has to equal AC over ED. So, we're going to say AB, 12 over 18, has to equal 10 over X. And then we'll just do cross products. So we're going to get 12X has to equal 180. So you will divide both sides by 12 and get X to be 15. So DE is going to be 15. Now let's look at quick check number 3. First, tell me how you know that these 2 triangles are similar. Hopefully you will agree they are similar by AA similarity, because you got 2 pair of angles that are congruent. Now please pause the video while you set up a proportion to figure out X. I have set up the proportion 6 over X equals 8 over 12. Now 6 goes from 1 arc to 2 arcs, and X goes from 1 arc to 2 arcs. The 8 goes from 1 arc to no arc, and so the 12's got to go from 1 arc to no arc, which it does. Now, to solve this, again, we're going to use cross products, and so 8x has got to equal 6 times 12, which is 72. 8x equals 72. Divide both sides by 8, and you get x to equal 9. Example 4, ask Ramon to try to measure the height of the geyser indirectly. Now, we've done a couple problems in the past where we've measured indirectly. I remember we measured the distance across the lake one time indirectly. We didn't string a tape measure straight across the lake. We measured the distance across the river with Napoleon's officer indirectly. And we're going to do the same thing here. You can't measure the height of the geyser directly. You can't set up a step ladder right beside the geyser and then string a tape measure as it erupts. I mean, that water is scalding hot. So let's see how Ramon's going to do it. It says, first he walks backwards. He sets a mirror when the geyser is not going off. You can measure the distance from the base of the geyser to the mirror. And he gets that to be 40.5 feet. Then, when the geyser erupts, he walks backwards until he looks down in the mirror and can see the top of the geyser. Now, Ramon is 6 feet high, and he measures that when the geyser is erupting, and he's looking at the top of it in the mirror, he is 7 feet from the mirror. All right, so you can see the two triangles that are set up, and you know the angles are going to be congruent because the angle that he looks down in the mirror and reflects to the top of the geyser, those two angles are going to be congruent. So see if you can figure out how Ramon is going to get the top or the height of the geyser. Now the first question I should ask is, how do you know these two triangles are similar? Well, Ramon is standing perpendicular to the ground, and the geyser erupts perpendicular to ground. So angle T and angle S are both right angles, and all right angles are congruent. And like I already said, the angle that light hits the mirror, it's going to reflect at that same angle off the mirror. So angle HVT and angle JVS are also congruent. So the two triangles are going to be congruent by AA similarity. Now, please pause the video while you set up a proportion to get the height of the geyser, or X. Now I've set up the proportion 6 over 7. The height of Ramon's triangle over the base has to equal the height of the geyser over the base. I've set this up a little bit different than the book. Hopefully you're not looking in the book when you're trying to figure these out. Hopefully you're trying to figure them out for yourself. So, and then we're going to do cross products. So it's going to be 6x equals, and punch that into a calculator, you're going to get 243, and then you would divide both sides by 6. So the height of the geyser is going to be approximately 34.7 feet high. About 35 feet high is the height of the geyser. For our last problem, quick check number 4 asks us to get the height of the cactus. Now, we don't know the height of the cactus, but we know at a certain time of day the cactus is casting a 9-foot shadow, and at the same time a 6-foot tall person is casting a 4-foot shadow. So first I'd like to know how you know the two triangles are similar, and then set up a proportion to solve to get the height of the cactus. Please pause the video while you tell me why the two triangles are similar, and then get the height of the cactus. Well, the way you know the two triangles are similar is, first of all, the person and the cactus are both perpendicular to the ground, so they're right angles, and all right angles are congruent. And the sun is so much bigger than the earth and everything on the earth, so these angles of the sun across the top of the person's head and the sun across the top of the cactus are going to be congruent. So the triangles are congruent by AA similarity. Now, please pause the video while you set up the proportion. Again, the way I've set up my proportion is 6 over 4 equals x over 9. The height of the person over the person's shadow has got to equal the height of the cactus over the cactus's shadow. Now, of course, there's more than one way to set this up. We could have said the height of the person over the height of the cactus has got to equal the shadow of the person over the shadow of the cactus. But either way you do it, your cross products, you're going to have 4x has got to equal 6 times 9. 4x has got to equal 6 times 9. 4x, 6 times 9. So 4x has got to equal 54, and you divide both sides by 4. And you get the height of the cactus to be 13.5 feet. This concludes Lesson 7.3.